Alright, this is the Chapter 23 test review, and something you might want to be aware of is that the real test will have about 50% problems like I'm going to go over in this review and 50% concepts, which I will not go over, and you'll have to look these things up and read about them in the chapter. Question 1A. The company provided the following direct material cost information, and they want you to compute the cost variance. The cost variance, another way to say that would be the total variance. And so what you're trying to do is you're trying to compare everything at standard with everything at actual cost, and that difference between everything at standard and everything at actual is considered the total cost variance. So let's do that. So we have direct material cost at standard 416,000 units at $6 per unit, and we have actual costs that we incurred of 414,750 units of this material at $6.20 per unit. And it looks like the actual cost of 2,571,450, which is the actual at actual, compared to the standard at standard, which was 2,496,000, gives us a variance that is unfavorable in the amount of 75,450. It's unfavorable because anytime that the actual is higher than the standard, it's unfavorable. If the actual is lower than the standard, then it's favorable, but this is unfavorable. So that's the total cost variance. Number 2A. A company's flexible budget for 16,000 units of production showed sales of 96,000, variable cost of 56,000, and fixed cost of 20,000. The operating income expected if the company produces and sells 20,000 units is what? Well, since this is a flexible budget, we're going to first of all put down the format we're going to use. Sales minus variable cost equals contribution margin minus fixed cost equals operating income. And this is a flexible budget, which means that things change when volume goes up and down. So if this is the budget for 16,000 units, sales of 96, variable cost of 56,000, and fixed cost of 20,000, then we're going to make a budget based on 20,000 pieces or 20,000 units. Okay, so here's what we got. We know, by the way, we know that on the existing budget, the sales minus variable cost equals a contribution margin of 40,000 minus fixed cost of 20,000 gives us operating income of 20,000, but we don't care about that. What we care about is breaking this into pieces so that we can redo the budget based on the new volume level, which is 16,000 units. All right, so we've got $40,000, which is the contribution margin, divided by 16,000 units, which we are currently operating at, means that our contribution margin per unit at this level is $2.50. And so if we change the budget to 20,000 units, then our contribution margin now jumps to a total of $50,000. It was 40,000. That was 40,000. It was 250 times 16,000 units. Now it's going to be 250 times 20,000 units, or a $50,000 contribution margin. And our fixed cost, because they are fixed costs, stay the same at 20,000. And now our operating income, our operating income was 40 minus 20 or 20. Now it's going to be 50 minus 20 or 30. And that's the answer we're looking for. All right, let's go to 3A. Based on production of 36,000 units, the company anticipates $882,000 of fixed cost and $801,000 of variable cost. The flexible budget amount of fixed and variable costs for 34,000 units would be what? Okay, let's set up our situation here. We've got, since production's going from 36,000 units to 34,000 units, fixed costs don't change, so they remain the same. But variable costs will go down proportionately. But let's see how much. So if fixed costs stay the same no matter what volume we're operating at, whether it's 34,000 units, 36,000 units, or even 0 units, our variable costs are going to go, let's see, $801,000 was the total variable cost at 36,000 units. Okay, so that means that the variable cost per unit was $22.25. And if we want to see what the total variable cost is for 34,000 units, then all we have to do is multiply that variable cost per unit times the new volume level of 34,000 units, and we'll get what the total variable cost is at that volume level, which is $756,500. And then if we want to know what the total costs are, let's see here. Yeah, that's how we made the calculation. The 801, which was the current volume of total variable cost, divided by that level that we were currently operating at, 34,000 units. That fraction times 34,000 units gives us $756,500. And now we're on to number 4. Kiwi has a sales price of $16 per unit based on 13,000 units of production. The variable costs are $8 per unit and fixed costs are $6 per unit. Using a flexible budget for 15,500 units, what is the budgeted operating income? So we're going to go from 13,000 unit budget of production to 15,500 and see what the costs are. So currently, let's see, costs are $16 per unit, and if we change that volume from 13,000 to 15,500, it'll be 15,500 times $16 per unit, or the current sales level at 15,500 will be $248,000. And then variable cost, still based on the same 15,500 units that we're trying to find out, times $8 per unit, which is what that said it was, would be 124,000. And now here's something that's interesting. That the only thing that really matters in this problem is this next step. Fixed costs are fixed costs no matter what. So if the fixed cost were $6 per unit at 13,000 units, that's going to mean that the total fixed cost would be 6 times 13,000 or 78,000. And it doesn't matter if we change the volume to 15,500, because those fixed costs will still remain the same. What will happen is, if you want to get fixed costs per unit, since the fixed cost went up, there'll be a lower fixed cost per unit, but you don't even have to do that. All you have to know is that fixed costs remain fixed. And so the operating income will be the sales at the new level, 15,500, variable costs at the new total volume level of 15,500, 124,000, and the fixed costs are going to be fixed at the total fixed cost amount of $78,000. Number 5A. Company's flexible budget for 14,000 units of production reflects sales of 280,000, variable cost of 98, and fixed cost of 91,000. Calculate the expected level of operating income if the company produces and sells 17,000 units. So we're going to go from 14 to 17,000 units. So we have this little setup here. We'll say at 14,000 units we had $280,000 of sales, and we also had variable cost of 98,000, and we also had fixed cost of 91,000. And then at 17,000 units, our sales, well, hold it, before we get to that, we're going to say sales minus variable cost equals contribution margin at the 14,000 level of 182 minus the fixed cost of 91 gives us operating income at the old volume level of looks like 91,000, but we don't care about that quite yet. But what we're going to do now is we're going to say this $182,000 contribution margin at the old level divided by 14,000 units at which was the old level of units, means that our contribution margin per unit is going to be $13 for each unit that we sell. That's how much money we're going to make. And now if we apply that to our new volume level of 17,000 units, we'll say that $13 times 17,000 will give us a $221,000 contribution margin, which goes right there. And our fixed costs remain the same at 91,000, and it looks like our operating income at the new level of 17,000 units will be $130,000. 6A. Based on a predicted level of production and sales of 20,000 units, a company anticipates reporting operating income of $22,000 after deducting variable expenses or variable cost of $120,000 and fixed cost of $18,000. Based on this information, budgeted amounts of fixed and variable costs for 23,000 units would be what? So we're going to go from 20,000 units to a 23,000 unit budget and see how things change. So fixed costs should remain the same. That's no different. That'd be still the 18,000. And variable costs will be, first of all, we got to figure out what the variable cost per unit was at the old level. So if our total variable costs were $120,000 at the old level, and that was based on 20,000 units, then our variable cost per unit is going to be $6 at the old level of 20,000 units. It doesn't really matter what that level is, but it's $6 per unit. And so variable costs of $6 per unit times the new level of volume of 23,000 means that our total variable cost at the new level will be $138,000. And so another way to look at that would be, another way to say the same thing would be 120,000 divided by 20,000 units at the old level. That piece, which would be $6 per unit, times the new level of volume, 23,000 units, will be 138,000. Same way, either way you want to figure it. Number 7A. Smith Company has the following data. What is the actual cost of direct materials used? So it looks like the standard for direct materials is 2 pounds at $3 per pound. That's the standard, which is a total of $6 per finished unit. Total direct material cost variance is unfavorable to the tune of $14,750. In other words, we spent, our actual costs were more than what the standard calls for by the amount of $14,750. Let's see, actual direct materials used were 90,000 pounds and actual finished products produced was 30,000 units. So what we're trying to find out is, what was the actual cost of direct materials used? Well, if it takes $6 per unit to make a finished unit, and we actually made 30,000 units, then the standard for this would be $180,000. And if we know that the total direct material cost variance was unfavorable, that is, the actual cost was higher than the standard cost by $14,750, all we've got to do is take this number, which is making 30,000 pieces at the standard, and add that to it. And that'll give us what the actual material costs were. So that'll be actual material cost of $194,750. Number 8A. Smith Company has the following data. What is the direct material quantity variance? Okay, they gave us direct material standards of $3 pounds rather at $1 a pound, which is $3 per finished unit. The total direct material cost variance is unfavorable to the tune of $14,750. Actual direct materials used are 120,000 pounds. Actual finished units produced are 30,000 units. And so we want to know, what is the direct material quantity variance? Alright, the quantity variance is a formula that looks like this. You take the standard price and you multiply it times the difference between the actual quantity and the standard quantity allowed for whatever level of production that you had, which was, you made 30,000 units. So what's the standard quantity material allowed for making 30,000 units? And compare that to the actual quantity that's used. So you used actual material of 120,000 pounds, which is this piece, and the standard for material is $3 per pound, or excuse me, $1 per pound right there. So you got this piece, so you got $1 per pound, actual quantity is going to be 120,000 pounds, and the standard quantity allowed to make 30,000 units is going to be what? Well, it's going to be, looks like 30,000 times 3 pounds, which is the standard, or 90,000. So 90,000 is going to be right here. And so it's $1, which is the standard price, times the difference between the actual quantity that we used, 120,000 pounds, compared to the standard quantity allowed to make 30,000 units, which would be 30,000 times 3, or 90,000. So it looks like we're going to have 30,000 in the brackets here. That's the difference, times $1, or $30,000, and the variance is going to be unfavorable because the actual quantity was higher than the standard quantity. So it's an unfavorable variance anytime we use more than the standard. 9A. Smith Company has the following data. What is the direct material price variance? Okay, here's the price variance formula. It's actual quantity times the difference between the actual price and the standard price. So let's figure this out. The budgeted direct materials were 25,000 pieces. We made 25,000 of these pieces, and at standard, which is let's see here, budgeted direct materials, $3 each. So the finished unit each finished unit is $3 per unit. So the budget for making this would be 25,000 times this units times the $3 per unit, which is $75,000. Now, the unfavorable direct material variance, which was given to us right here, cost variance was unfavorable, $22,500, should be added to get the actual amount that we spent for direct materials. So if you find things at the standard, which is 75, here's what we should have spent $75,000, but we had an unfavorable cost variance of $22,250. So therefore, that should be added to this to get the actual cost of materials used, which was $97,250. And looks like that we have let's see what else here. $97,250 is what we spent for actual cost of materials, and if we had purchased 100,000 pounds of material, which was the actual amount of materials that we used, if we divide that 100,000 into the actual amount we spent, we'll get the actual cost per pound of material, which is 97 cents, basically 97 cents. Okay, that's what we're looking for. We're looking for what is the direct material price variance. Okay, so the price variance is going to be the actual price that we paid for this material, which was 97 cents, a little over 97 cents. The standard for the material is $1 a pound, and the difference between the two times the actual quantity that we used will give us our price variance. In this case, the price variance is going to be $2,750. And it's going to be favorable because the actual price was lower than the standard price. 10A. What is the direct material cost variance from the information below? And they give us direct labor standards, which to make a unit you got to spend on standard. You got to have 4 hours of labor at the standard, and $7 per hour is the standard for labor, or each unit in terms of direct labor would be a total of $28 worth of labor. That's at standard. Actual hours worked per unit were 3.5 per unit, and actual units produced were 3,500 units, and the actual rate per hour was $7.50. So they want to know what's the labor cost variance. Okay, so the labor cost variance is the same thing as really saying, like, what is the total labor variance? And so what we're going to do is we're going to compare actual hours and at actual rate, which would be 3,500 actual hours we made 3,500 units, and so 3,500 hours times 3.5 hours per unit, which is what we has as an actual rate, times 750 per hour, which is the actual rate for labor. Looks like, let me start over again here. We're trying to get the actual hours and actual rate at the actual units that we produced. So it's 3,500 units that we produced times 3.5 hours per unit, which was the actual hours that we used to make each unit, times all that's times the actual rate that we paid, which was $7.50. So that means our total amount of actual labor in dollars was $91,875, and we're going to compare that to the standards, what the standards should have been to make 3,500 units, and that'll give us our total labor cost variance. So let's do it at the standards now. At the standards, we made 3,500 units, and the standard calls for using 4 hours of labor, and it calls for using a $7 per hour rate. And when you run all that through your calculator, then the standard amount of labor to make 3,500 units would be $98,000, and we only spent $91,875. Therefore, it's going to be a favorable variance to the tune of $6,125.